So let's talk about ATP calculation. So if you have certain molecules or certain number of glucose or other intermediate of glycolysis, you may want to know how many ATP molecules are formed approximately. So let's start from the basics. So for glucose, when glucose is broken down in glycolysis, it's going to yield 2 molecules of pyruvate, right? So, but you have to know each step what energy molecule is formed or energy molecule is used. So there's a difference between net ATP and technically total ATP, or like the grand ATP. So for glucose in glycolysis, so very important to note that when you ask how many ATP molecules are formed from glucose, when it is totally broken down or just in glycolysis. So we'll talk about everything. So let's start from glycolysis, because there are 3 steps here technically. So we have glycolytic steps as one, and we also have the transition. That's after you form pyruvate. Pyruvate is converted to acetyl-CoA. There's also going to be energy that's going to be yielded from that. Then after that, we are going to have acetyl-CoA being used in Krebs cycle, and there are also going to be ATP formed there. So glucose is converted, you already know, to glucose 6-phosphate, right? And in this process, where glucose is converted to glucose 6-phosphate, we are going to use 1 ATP molecule. Also, from fructose 6-phosphate to fructose 1,6-bisphosphate, there's going to be 1 molecule of ATP used. Meaning, in total, we are using 2 ATP molecules in glycolysis. So this one is for the preparatory phase. Next, where we are going to have the payoff phase, where we're going to begin to have energy, like our salary from after using this, what are we going to form? So we're going to have gap and gap, right? So that is from fructose 1,6-bisphosphate. But it is the glyceraldehyde 3-phosphate that's going to be converted to 1,3-bisphosphoglycerate. And how many ATP molecules are we going to get? It's going to be indirectly, because we are going to form 2 molecules of NADH. So the 2 molecules of NADH that are going to be formed based on the shuttle, like I said, so we have 2 pathways. We have what's called glycerol 3-phosphate shuttle, and we have the malate aspartate shuttle. Why do we need a shuttle? Because glycolysis takes place in the cytosol, and energy from NADH can only be gotten in the mitochondria. So we need to transport NADH from the cytosol into the mitochondria. So there are 2 pathways that can happen. Either we use the shuttle of malate glycerol 3-phosphate or malate aspartate shuttle. So if we use the malate aspartate shuttle, we are going to yield approximately 5 molecules of ATP. And that's like the standard shuttle that we mostly use in our calculations. But glycerol 3-phosphate shuttle will yield us 3 ATP molecules. But in other situations where we're going to form NADH, we're going to use 5 ATP molecules, because most of the other NADH molecules that are formed are mostly in the mitochondria. So we're going to form 5 ATP molecules from 2 NADH. Also, from 1,3-bisphosphoglycerate to 3-phosphoglycerate, we're going to remove 1 phosphate and we're going to add it to ADP. We're going to form ATP. And finally, the conversion of phosphoenol pyruvate. Phosphoenol pyruvate is converted to pyruvate, and that process also involves the formation of ATP. But how many ATP? Remember, when we formed DAP and GAP, the DAP was converted into GAP. So we have technically 2 molecules of glyceraldehyde 3-phosphate. That's even why you are seeing it being doubled, NADH Here also we are forming technically 2 ATP molecules and 2 ATP molecules. So by glycolysis, how many ATP are formed? So we are having 5 ATP, right? Plus another 2 ATP here, plus another 2 ATP molecules. So in total, we have 9 ATP molecules formed. But we use 2 ATP molecules in our preparatory phase. So if we're asked, what is the net ATP formed? Will be equal to the 9 ATP that have been formed minus the amount of ATP that is used to yield the 9 ATP molecules. So in total, we have 7 ATP molecules from 1 molecule of glucose in glycolysis. This is just for glycolysis. Now that we have formed 2 molecules of pyruvate, technically, so pyruvate, so now we know pyruvate is also going to be converted into acetyl-CoA, and it's 2 molecules, by the way. And during this process, this is a transition. This is a transitional process. So 2 NADH molecules are formed, where we can form 5 ATP molecules, 5 ATP. Also, the acetyl-CoA that the acetyl-CoA molecules that have been formed will go to Krebs cycle, where we are going to yield for two acetyl-CoA molecules will be equivalent to 20 ATP molecules. So in summary, what do you need to know about the energy yield? So given that we have formed a lot of NADH, right, and also FADH2, and in one scenario we formed GTP alias ATP, we need to calculate. So during our cycles, what did we form? So we formed in one scenario NADH, right? Then another scenario we have formed 2 molecules of NADH. Then we have also formed 2 molecules of GTP, right? And another scenario we have formed 2 molecules of FADH2. And in another scenario we have formed 2 molecules of NADH. So let's write them down. So from isocitrate to alpha ketoglutarate, we formed 2 molecules of NADH. Then from alpha ketoglutarate to succinyl-CoA, we also formed 2 molecules of NADH. Then from succinyl-CoA to succinate, we formed 2 molecules of FADH2. Then from malate to oxaloacetate, we formed 2 molecules of NADH. And remember one more, from succinyl-CoA to succinate, we form 2 GTP. So let's go over that again. From isocitrate to alpha ketoglutarate, 2 NADH. Alpha ketoglutarate to succinyl-CoA, 2 NADH. Succinyl-CoA to succinate, 2 GTP molecules. From fumarate, from succinyl-CoA to fumarate, we form 2 FADH2 molecules. Then from malate to oxaloacetate, 2 NADH molecules are formed. So in total, let's calculate how many ATP molecules are generated. So we already said 2 NADH equals 5 ATP molecules. 2 NADH, 5 ATP molecules. 2 GTP, 2 ATP. Then 2 FADH2 equals 3 ATP molecules. because 1 FADH is equal to 1.5. Then 2 NADH is equivalent to 5 ATP molecules. So now, as you can see, we have 5, 10, 15, 20. So in total, 20 ATP molecules are formed by the Krebs cycle. So what does this mean? It means when we're having 1 molecule of glucose, we're going to form 20 ATP molecules by the tricarboxylic acid cycle. Meaning, if you're having 20 ATP, that means 1 acetyl-CoA molecule will give you 10 ATP molecules.